right. Hi, everyone. Good morning. Thank you so much for being here with me today. I'm very happy to have each of you joining this session. My name is Sujeily Fonseca-Gonzalez. For today, the session will be Bridging DevOps and GitOps, Multi-Cloud Strategies for HyperScaler. This session is so that you can you can understand how you could use compliance in multi-cloud and highly regulated environments so that you can know how you can secure your system. To get to know a little bit about me, I'm come from Puerto Rico, from the University of Puerto Rico at Maya West Campo. I'm a software engineer manager, technical program manager, and technical leader for IBM within the software unit. And throughout my career, I have had different roles in software development, automation, web development, full stack development, as well as managing program and releases for IBM and managing high performing engineering teams. Besides that, I like engaging with the technical communities in the company and also with the ERG, BRG, particularly with the Hispanic community in my company. Now, why we are here, there is a market today with highly regulated deployments. We have federal industry, regulated industry, and there is opportunity so that you can have your deployments in different clouds like AWS, IBM, Google Cloud in a compliant way so that you can compete in this market. This is market that have high demands. There is high money also involved in this market, but there is no much people at the moment with the right guidance to get into this market at the moment. What is the challenge that we have today? That DevOps as it is not enough for this market. You need to think about compliance. You need to think about how you put the compliance since the day one as you develop your workload, your deployment, so that you can build that deployment and the software with confidence. There is opportunities so that you can expand into multiple clouds. You could go into regulated and federal industries like FedRAMP, Protected B, HIPAA, and others. But how you could do that is just by having the mindset that is not deploying here and here and here, is deploying in a way that you're prioritizing the compliance, you're prioritizing securing your deployment, and you deploy not only in the cluster, you deploy with confidence. Now, for today, there will be several topics. I'm going to talk about the evolution of DevOps and GitOps, key advantages that you have around the GitOps model, how you associate the DevOps and the GitOps practices, some open source technologies that you can consider. There will be just a set of those over here, but there are more that you can include while thinking about compliance, DevOps, and regulated deployment, how you could use them for orchestrating your deployment. What are some challenges that you could have from a multi-cloud perspective, but also from a compliance perspective? Some of the compliance standards and frameworks that are involved when you're trying to deploy to HIPAA, Protected B, FedRAMP, SOC 2, and other compliance accreditations. Also, how you could using Argo CD as an example, that tool for GitOps enablement, and what to consider for the deployment configuration, that meaning the manifest that you use to define your deployment inside the cluster, and evidence collection, what that means, what to include over there, and some of the lessons learned that I have had. So for evolution of DevOps and GitOps, in the traditional GitOps, usually pipelines were manual, they were scripted, there were a set of tests that we had to follow, but there was no way of identifying if someone went to my cluster, modified my deployment, how can I detect that? How can I incorporate and reconcile to the desired state that I have? So with GitOps, that is moving into having Git as the desired state. You define your deployment configuration as code. There is any variation of what those configurations you have a way of detecting that drift within your deployment. You use Git as a source of truth for your deployment, which in a way will give you all the Git capabilities to identify who made the changes or what were those changes that were made, which in a way you will learn as we go through this, that also help from a compliance standpoint so that you could keep your evidence of your deployment for any audit or compliance accreditation. There is also the commit history, so that give you an idea on an historical data of the changes that were made. But more importantly, we're shifting towards tools to intend to automation. So my desired state, what I save into my cluster, what I deploy into my cluster, what I save into my GitHub as the desired state for my application, that is my intent. And the goal is to use automation to enforce that state so that if something differs from that, you reconcile to that desired state. There are some stats over here that support the move into the GitOps industry. Like, for example, 60% of Kubernetes cluster today use Argo CD. 97% of those run in production. 60% of GitOps users have been running it for more than a year. These are stats from the Cloud Native Computing Foundation, but what this basically means is that people are less afraid of using open source technology for production deployment for enterprise level solution. And these are tools that are at our disposition so that we could enhance, contribute to them so that we can compete into the regulated market and deploy in a compliance way. There are several advantages of GitOps. I'm just focusing on a few of them. But first of all is the declarative configuration. You're keeping your deployments as code. Everything that you're orchestrating, if you have a UI, you have your service, your deployment, stateful set, config mask, secret, all that is structured as code. And as I mentioned before, you use the automation to reconcile to that desired state to make sure that your deployments are what you want to have. There is enhanced automation efficiency as well, because since you're keeping your configuration as code, you're minimizing human error. If you are going into multiple cloud, cloud A, cloud B, cloud C, you don't need to reinvent the wheel or have something different when you go to the different clouds. You can standardize and maintain consistency across the environment and deployments that you have. Because of if you use tools like Argo CD or others, they enable you to do self-healing capabilities so that you can recover and maintain your tool in a reliable way. Because of that, that also enables some of the some faster releases and streamlines your CI/CD development and practices and operation. Last but not least is improve auditability and visibility. Since with GitOps, you use Git as the source truth, that let you have all the capabilities that you have for Git. So who made the changes? What were the changes that we made? When or where we made those changes? Who authorized those changes? All those are important questions and aspects that you need to consider for keeping a record of your application, but at the same time, to make sure that you have an audit record, historical data that you can use for an audit as you go to different compliance accreditations. Considering the DevOps and GitOps practice, we need to make sure that we use CI/CD for efficiency, streamline our processes, enhance our collaboration, and reduce our deployment times, so that we use this as a tool to expand to multiple clouds and compliance program. Automation for consistency. I'm mentioning that automation part over and over because it's key that you incorporate that at early stages in your deployment to reduce manual human error, to reduce manual processes, to try to ensure that your deployment orchestration is a repeatable process, something that you could do for one cloud, but then for the next cloud is the same process as an overall. And evidence tracking for compliance. If you're thinking about going into a protected B accreditation, HIPAA, any other expansion, evidence is very important because you need to demonstrate to the auditors that you're deploying in a compliant way, that you have that record that can support that you're not just doing the deployments in a secure way, how you're doing them, where you have the evidence that could prove that. Now, there are different open source technologies that you could consider. This is just a set of those, but you can have for GitOps orchestration tools like Argo CD, Red Hat GitOps Operator, which in a way is a variant of the Argo CD. There is Flux Nginx for CI. There is Tecton, One Pipeline. There are others. Ham Customized JSONet for config and packaging. There is Secret Manager. You could use Vault. You could also use Cloud Native Solutions for Secret Manager. For policy and compliance, there are security scan solutions, there are signing services, For observability and evidence, you have Prometheus, you have Grafana, you have Loki. There are also others for infrastructure as code, Terraform, Atlantis, Crossplane. There is a lot of tools that we have and we could use to our advantages. What to use depend on your use case. What is the product or software that you're trying to deploy? What is the compliance accreditation that you have to meet? Is that tool compliant with the requirements that you have? All that is what you need to take to keep in mind to decide which tools to use. But all of them are tools that we could leverage and also contribute back, because it's not only using those tools, but if you feel that they have a benefit added to your organization and you can enhance them, it's better to contribute back to those communities and let others take advantage of the innovation that you could put over there. Now, for the next couple of slides, I'm going to deep dive a little bit more into the compliance accreditation, some of the compliance aspects that you need to take in mind in regulated environments. So for that, there are a couple of terms that I want to make sure we discuss before. First of all is out of the boundary versus inside the boundary. When you have a regulated environment, the boundaries is that environment that you're evaluating for the compliant accreditation. So that define which services, data, and integrations are included in that environment that you're evaluating for a compliance accreditation like FedRAMP, HIPAA, or SOC 2 and others. Out of the boundary normally means non-sensitive information or integrations that can reside outside of that environment. While inside the boundaries, all the sensitive information, classified data that you manage for the customer, any evidence that you maintain defining the compliance of that particular environment. Data sovereignty is that the data must remain in a particular geographic location or jurisdiction boundary. For example, if you're doing FedRAMP, that is related to the US government and agencies, so the data or classified data must reside within the US boundary. And then boundary restriction is what you do to maintain that environment up to the compliance level that you're looking for. So private networks is normally more secure than public network. If you don't need to expose your services into the internet, try to keep them insulated within the private network. Access control, you define who accesses your system, what level of permissions they have for your system, and the different kind of evidence that you have that define the restriction to the boundary. Now, there are different challenges that you may encounter from a multi-cloud and compliance perspective when you're thinking into moving into regulated environment and have your workload being evaluated over there. Starting from a multi-cloud perspective, number one is environment consistency. If you have, you're deploying into IBM, you're deploying to AWS Cloud, to Google Cloud, and so on, you don't want to create something new when you're moving to AWS and you're now deploying to IBM Cloud and so on. You need to make sure that the way you're deploying is consistent all across. So your deployment configuration, how you keep your code and desired state in Git need to be consistent all across. Enforce reconciliation and try to prevent drift across all the clouds so that you can maintain your environment as consistent as possible. And help and customize or any approaches that you're using to deploying, try to generalize as much as possible. For example, if you're using Argo CD for your deployment, anything is environment specific, like this is my cluster configuration, my namespace, where I'm deploying to, that depends on the environment. But the rest, if it is a UI application, config map structure, secret structure, the service, the deployment, all that could be generalized, so you could have templates for all the deployments in the different clouds. Tooling consistency, if you know you're deploying to different clouds and multiple environments, try to see what is common across all those environments. If you have Azure as your cloud, IBM, and you're using OpenShift Container Platform to deploy it across the multiple environment, what tool you can use for continuous delivery that is the same across. Argo CD could be a solution, or it could be something else that in a way is as per your requirement. Compliance and data residency, that depends on the compliance accreditation, the requirements you have over there. but any policies, try to have them as code, separate your repositories or structure your repositories in a way that you comply with the boundaries that you have. And networking and connectivity, as I mentioned before, try to secure everything if you're entering into regulated environment, because if you don't need to keep a UI exposed, or or any deployment private endpoint APIs exposed, try to keep them within the private network. If the UI application need to be out there in the public network, then you could have certificate validation, you can have different checks for compliance, access control, so that nobody can just hit your endpoint and try to enter into your application. Identity and access, OIDC, role-based access control, those policies as code as well. How you manage your secret, you use tools like Vault or any other tools that you consider is appropriate for your use case. And you define process for observability and operation. Those metrics, audit logs, they're useful for audit purposes, but also to troubleshoot if something changed, if somebody changed your applications, that's the place where you have that historical data of what happened over there. And finally, cost and portability. Cost, meaning if you need to standardize as much as possible to reduce the infrastructure costs, but also operational costs. If you need to maintain something different between Cloud A and Cloud B, then that is increasing your development workload. That is increasing the time that your developers need to spend maintaining those environments. So reuse manifest as much as possible, standardize as much as possible. And if you have a compliance accreditation for an environment that is highly regulated, like FedRAMP, you have other environments that are not regulated, like a commercial space, or something that is less strict, like a protected B versus FedRAMP. There is some flexibility in the protected B space. Then if you have FIPS compliance component, hardened base image for that FedRAMP deployment, and nothing prevents you from using it in the non-regulated environment, use those images all across, because that will make your non-regulated environment more secure, but at the same time, you're reducing time and overhead into maintaining those environments. Now, from a compliance perspective, there are different requirements that you need to take in mind. First, security boundaries. Depending on the regulation that you're trying to, or the compliance accreditation that you're trying to achieve, you need to think about how you manage the data, how you manage the operational integrity, so that you can be compliant in that regulated environment. Data sovereignty that need to comply with local regulations, and in a way need to be considered while you're defining your architecture and deployment. So if, for example, if you're doing a protected B deployment, some of the workload, because that is dealing with Canadian government and agency, need to be in the Canadian region. So think about that so that you can orchestrate and architect your deployment architecture in a way that you keep the workload where you need to keep them. And finally, tool fragmentation that could cause some inefficiencies. So develop solutions that can streamline management and compliance processes as an overall. Now, these are some of the example frameworks for compliance standards. We have ISO, we have HIPAA, we have PCI, DSS, EDPR, NIST, SOC 2. I'm not going to deep dive into the details of what each of these mean, but why I would like to bring this to your attention is because if you're pursuing a compliance accreditation for FedRAMP, you need to be familiarized with the controls that define how you need to define that environment. So, for example, FedRAMP for high and moderate accreditation, you need to be familiarized with the NIST. If you're doing protected B, you need to be familiarized with ISO and NIST. So try to get to know those controls, what you need to do for access, what you need to do for networking, what could be in the public, what could be in the private network, so that when you deploy, when you build your architecture, you keep those in mind and you don't, again, do something different every time you're going into a new accreditation. And if you have commonalities and you have a multi-cloud environment or multi-tenant environment, if you see commonalities between HIPAA framework, between the NIST, between the protected B requirement, you could build, in a way, commonalities depending on the compliance levels that you need to achieve. Now, there are other compliance considerations that you need to have depending on the area that you're focusing. So this is more from a DevOps and GitOps perspective. What to consider for your workload and deployment. So if you think about DevOps, GitOps, CI/CD, is access control and segregation of duties, role-based access control, least privilege, separation of duties, how you have access defined in a way that if your developers in production should only have read-only access, you define those policies. If SRE is the one that need to modify your production environment, you define those policies and maintain them. You enforce those policies as well, keep them as code so that you can easily manage them. You define a process so that you can have compliance gates. That meaning that if you're moving from development to test environment to pre-production and prod, you don't make a change in development that goes straight to production. There need to be some gates in between that allow you to deploy in each environment in a secure way and having some compliance and tests that can prevent you from moving forward if you're not meeting those standards. Define a change control process so that there is a process for reviewing your deployment, the changes that you would like to make, and approving those changes before they go into the production environment. Also, immutable artifact and provenance, that meaning, for example, if you have container images, that you're signing those images, that you're keeping version to those images, that they are coming from trusted registry, that you're scanning those periodically so that you can make sure that they are compliant, that you're remediating vulnerabilities depending on the ITSS or the standards that you have for remediation. Secrets, avoid exposing obviously the secret over the version control system, have a secret manager integration. Audit logs, evidence capture, those are important again for both reasons, troubleshooting, but also you need to save all that data so that if you're going through an audit to try to get a compliance accreditation, you have the historical evidence of that. Data residency and sovereignty, those define how you deploy your workloads, how or where you keep those workloads. Environment isolation, have separation between the clouds, if you're doing AWS, IBM, and so on, but also between environments so that you can define who have access to those environments, who could modify those environments depending on where you are. Configuration and drift control so that you can keep everything as code and enforce that desired state. You reconcile if somebody made changes that were not authorized. Define a process for backing up your system, for recovering in case of a disaster, and roll forward or roll back. You can use either approach as long as you have a way of recovering if you deploy some changes and they are not working as they are supposed to. You have a process to react to that. Incorporate checks for third-party and open source technologies that you use to make sure that the license is something that you could use, for example, for production level deployments or enterprise solutions. Have a way of getting alert if something happened to your system, but reacting into that as well, because that is part of the process that you need to demonstrate for compliance accreditation. And tooling considerations, again, depending on clouds or depending on the environment, is what tooling you need to use for your solution. From a CI/CD perspective, there are different things that you need to consider at different stages. So for example, for CI, how you build your code, how you scan the code that you're building, those repositories associated to your CI integration, how you do unit testing in those CI integration, how you package those container images, artifacts that you're building through the CI pipeline, how you're signing those. And very important is storing the evidence of all those changes that you're doing as part of your CI integration so that you could use it for compliance purposes. From a CD perspective, there are checks that you need to do to make sure that you deploy before actually deploying. There is also how you define that deployment strategy, what you are going to do, or the process from moving from dev to test to pre-prod and prod. The amount of environment usually depends on your use case or how you manage that, but the essence is the same. How you validate those deployment after you do the deployment. You deploying and having everything green doesn't mean that it's working. It's making sure that it's passing the health check, making sure that it's working as it's supposed to be. and have processes to react if that is not the case. And again, very important, save the evidence around all the checks that you did, test results, verifications that you did in CD as well into an evidence locker. And we're going to deep dive a little bit more about the evidence concept in a moment. And as an overall, have a process for your secret configuration, for managing costs, for managing performance, for making sure that you have a reliable system that is portable and you can have all across. Now, there are different tools from open source that you could use and make sure that you could meet compliance accreditation. I'm going to use Argo CD as an example, but Argo CD is, in a way, what we use today for production and enterprise deployment. And you could do that if you consider some of the out-of-the-box capabilities that it has. So taking this as an example, one of the capabilities is the ability to declare everything as code, so your configuration as code, how you have automated things and you can reconcile in case something changed about that desired state, how you have the ability of centralize the management of cluster. If you have different cluster, you could keep them as code as well, manage the CRs and upgrade using the tool. You can use application sets. Those are very useful if you have multi-tenant or multi-region use cases. Progressive delivery, there is algo rollout that you can integrate depending on your use case to manage and orchestrate your deployment. There are different securities in integrations that you could use that are supported out of the box, like role-based access control, single sign-on, secret manager integrations with Vault or external secret manager operator or other system. There is also observability capabilities that are provided out of the box that you could integrate for metrics, for logs, for Grafana dashboard to see the health, sync, and status of your application. Namespace and project scoping, that is very useful if you have logical boundaries or if you have isolation where you need to have separation for segregation, also for separation of duties. Audit and evidence, Argo CD provide out-of-the-box audit logs that you could use for troubleshooting, but also those could be the logs that you parse into that evidence locker and you keep for compliance purposes. There are also sync policies, sync wave, and hooks that could help you define how you can orchestrate your deployment as an overall. Custom resource plugins that you could use to integrate with Vault, customize Terraform, and others, and the ability to deploy with high availability. In terms of deployment configuration, those are the manifests that you use to define the state that you want in the environment. So if you have config map, you have secrets, whatever manifest you have different ways of orchestrating and organizing those. One recommendation is segregating them. If you're using Argo CD as an example, there are different resources that or classifications that we could put over here. For example, have segregation per branch. One branch could be for application sets, for application. In a way, from an Argo CD perspective, anything that is part of the Argo project.io Kubernetes resource is considered an admin level resource. Why? Because that could expose indirectly access to your cluster. So keep those resources separate so you can define who are your admin, who is the one that have the authority of changing the version of your deployment, modifying your resources or admin level resources. There is also deployments. You can have a separate branch for those. Those are your cluster configuration, where you're deploying to, the cluster namespace, those details. You could segregate them in a different branch so you can have a separate access group controlling those resources. Those could be your developers and admin or just your admin. And then you segregate or separate the main manifest, which are all your deployments, resources, and you may want to have all your developers with the ability to modify the structure of your YAMLs and so on. This approach is just a recommendation, but usually help with separation of duties, help with clarity to know who can do what, and also enhance auditability because you have control over who can modify those particular resources. You can set some branch protection rules about who can change those resources for you. Evidence locker is something that we have been mentioning throughout the presentation, and it's very important because It's not only about, okay, I did the changes in a compliant way, it's how you prove that you did those changes in a compliant way. So that's why you could use the evidence locker, where you incorporate this concept into both CI and CD strategies, so that every time you do changes, you do security scan, you do checks, you store the evidence of that into your evidence locker. And it's very important that you do that in an automated way, so that you can keep a record and historical data that you could use for troubleshooting. But also, if you're going through an audit to try to be FedRAMP compliant, protected B compliant, it's very important that you have a way of proving that who have access to your system, who can modify all that, and what checks you can do when you do deployment. So all that is part of the evidence locker. There are different data that you can store over there, depending on the kind of environment or the stage in your pipeline. So from a CI perspective, you could do vulnerability scan report, you could do the hardening checks, you could do the build logs, you could do the licensing checks that you're doing in the CI stages, and also the outcome of each of the stages that you did from a CI perspective. Now, from a CD perspective, you could store Argo CD sync logs, the status, the Argo CD health checks, the deployment test output, the output of your promotion checks, and the outcome of each of the stages that you have on the CD. Now, I know I mentioned different concepts from a high-level perspective, but if there is any of you that have a specific use case or want to pursue a specific accreditation, I'm happy to chat. But from some lesson learned, one that is very important is governance before tool. Define a clear process for ownership, repository standard, promotion, something that you can replicate across your environment, across your clouds. Automate early, don't leave that to the very end, because something that could take you an hour today manually, in a couple of weeks could be hours, then it could be months, then it could be years. So incorporate that early in your process. Do not rely on cloud-specific tools if you are doing a multi-cloud model, because then you will have the overhead of maintaining a solution completely different when you're moving to cloud. Secure early. Security is very important, but normally is left to the end. So incorporate that since the early stages of your architecture and deployment. It's easy to remediate a couple of security vulnerabilities, but it's going to be more difficult if you put it at the end and then you have thousands to remediate in a very short amount of time. Segregate your environments and boundaries depending on the compliance accreditation and the regulations that you have. Automate the evidence collection. Again, that's very important for troubleshooting and compliance aspect. Validate those processes and collection very often to ensure that you have that historical data. Policy over platform. Standardize the security platform, the processes all across your environment, and contribute to those tools that are helping you meet the compliance. Contribute to the open source technologies that you have out there so that you can enhance them with whatever worked for you. It could also work for others. Last but not least is resiliency through GitOps. So test your processes, test the way that you do rollback, roll forward, the drift detection and reconciliation processes. And last but not least, documentation. Don't rely on a single person to try to know how your system works. Make sure that everything is something that another person could replicate. Now, to conclude, the scalability is not necessarily measured about, okay, I can expand, I can increase the amount of clusters that I have, I can increase the amount of clouds, or I can increase the CPU and memory for my resources. It's more about consistency, how you could scale, add more environment, add more cloud in a way that the process is replicable, in a way that the process is compliance, because you're building each environment in a secure way, and you're building the confidence in each of the deployments that you're doing for your cloud expansions or the different environment. Now, with that being said, I hope you enjoyed this session today. I'm happy to answer a couple questions before we get to the end of the session. But if you like this presentation, I put my link in over there. We can connect, and you can also rate the presentation in the application. So, any questions from anybody here? All right. If you have a question, raise your hand. All right, over there. So evidence locker is not a specific application, it's a storage place. So you could define, it could be as simple as a GitHub repository, but you need to control who has access to those, and that the data that you persist over there is immutable because you don't want a developer or somebody modifying that evidence. You want to keep it as it so that you can have a way of proving that that's how you're managing your environment. But it could be as simple as a GitHub repository, GitLab repository. S3 bucket is just a place that you store immutable data. All right, any other questions? Of course, I will send the slides. So if you could connect with me on the linking, I will send a copy of the slides. All right, any other questions? All right, then if you have questions, I will be around for a few minutes after, but thank you so much for your time today. I hope you have a good rest of your day.